Here I'm going to evaluate the limit of x to the power 1 by x as x tends to infinity. So we're going to use the calculus approach, a method called the L'Hopital's rule. I'm going to discuss what is L'Hopital's rule, when to use the L'Hopital's rule, and what are indeterminate forms. So here our first approach will be to substitute x with infinity and check the result. So if we put x equals to infinity, we get infinity to the power of 1 by infinity, and we know that 1 by infinity is 0. So here we get infinity to the power of 0. So we don't know what is the value of infinity to the power of 0. I mean, we know the value of 0 to the power infinity, which is same as 0, but we actually don't know the value of this. So this is called the indeterminate form. So infinity to the power 0 is called the indeterminate form. So there are a couple of indeterminate forms, and that's when we can use the L'Hopital's rule. So these are some of the other indeterminate form: 0 divided by 0, infinity, positive or negative infinity by positive or negative infinity, infinity minus infinity, 0 times infinity, 0 to the power 0, 1 to the power of infinity, and infinity to the power of 0 that we have in this case. So these are all indeterminate forms, and after substituting for x the limit, if we end up with one of these forms, we are gonna have to do further calculation. So one of the calculus approach is L'Hopital's rule that we can use. So I'm gonna do this math now, and we're gonna use the L'Hopital's rule over here. So the L'Hopital rule states that if you have an expression of this format, f of x divided by g of x, and we have to evaluate the limit as x tends to a, the limit will be same as f prime of x divided by g prime of x as x tends to a. So we are basically getting the derivative of f of x and g of x here, and then we will substitute the value of x with a, and whatever the limit we get is gonna be the limit of this expression. But in order to use the L'Hopital's rule, we have to have the expression in form of f of x divided by g of x, so that we can get the derivative of the numerator and the derivative of the denominator. So for this problem, we do not have the desired form. So because there is no denominator and no numerator, so in order to evaluate this, we are going to have to use the substitution method. Then we are going to use the L'Hopital's method. So let's use the substitution method first. So let's say y equals to limit of x to the power 1 by x as x tends to infinity. Now we are going to take ln in both sides. Ln y equals to limit x tends to infinity ln x to the power 1 by x. So the reason to bring out the ln here is that so that we can bring the exponent 1 by x in front, so that we can end up with a denominator. So let's rewrite this. Ln y equals to limit x tends to infinity ln x divided by x. So now I can see that we have the desired form. So this is f of x, and we can count it as the g of x. And now we are going to find the f prime of x and g prime of x. So we know that the derivative of ln x is equal to 1 by x, and the derivative of x is equal to 1. So let's just replace it. ln y equals to 1 by x divided by 1. So one thing to notice is that we cannot get rid of this limit notation until and unless we reach this spot. So we have to write, in every step we have to write this until we are substituting x for the limit. So now we just substituted x for the limit. So we know that we can write it as 1 by x. So now after this step we can just write, we still have to write limit x tends to infinity, and after this step we are going to substitute x with infinity, and this is exactly when we can stop writing the notation limit. So here you will notice I didn't write the notation limit because I don't have to anymore, because I have just substituted x for the limit. So this is not the limit yet because we have ln y equals to 1 by infinity, because at the beginning we stated that y is the limit, but we have ln y now, so we have to get rid of the ln. In order to get rid of the ln, we can just write y equals to raise it to e to the power 1 by infinity, that is equals to e to the power 0, that is same as 1. So the limit is gonna be equal to y equals to 1. So let us check if our limit is correct or not. So let's make a table here by x and f of x, the function, that is x to the power 1 by x, or we're gonna put, let's put the value of 10 here. If you put a value of 10, what do we have here? We have 10 to the power 1 by 10, that is equivalent to 1.259. Let's put x equals to 100, so we have 100 to the power 1 by 100, that is same as 1.047. Let's put x equals to 1000, we have 1000 to the power 1 divided by 1000, that is equivalent to 1.007. So you can see, as I am increasing the value of x, the value of f of x is reaching 1. It is going closer and closer to 1. So now we can say that as we increase the value of x to infinity, the value is going to approach to 1.